Hey, it's Mr. Engstrom. Let's take a look at day 2, probability rules. Here we go. The law of large numbers. So in the long run, experimental probability will equal the theoretical probability. The theoretical probability is the desired number of desired outcomes out of the total number of outcomes. Like if we flip a coin, the probability that we get heads, there's one way to do that out of a total of 2 possible outcomes, heads or tails. And what that means is as we flip more and more times, that's the long run, we expect or predict, right? We don't get necessarily exactly, but we expect the fraction of heads to total flips to approach 50%. We're getting close to that as more and more. So in the long run, as we flip more and more times. Okay, we know the probability can be written as a fraction, like 1/2, right? A decimal, 0.5, or a percent, of course, 50%. Okay, probabilities can't be less than 0. They can't be greater than 1. Probability of 0 means it's never going to happen. Probability of 1 means it's always going to happen. Law of averages doesn't exist for independent events. The sum of the probabilities got to equal 1, in other words, 100%. So this right here, this probability of not A, it's what we call the complement. Okay, complement. And it is 1 minus the probability that A happens. In other words, if we roll a die, the probability of not getting a 3 is 1 minus the probability of getting a 3. Next thing I need you to know is this term disjoint right here. Sometimes we use the term mutually exclusive if they cannot happen at the same time. All right, let's look at a couple of rules. We have an addition rule. Now, we're going to actually write it down 2 different ways. One that's in general, that's always true, and then we're going to change it just a little bit for disjoint events, meaning that there's no overlap in the probabilities. The events can't happen at the same time. But here's our general rule. What this symbol here, this symbol right there, that's union, and the word used there is or. So what we're finding is the probability of A or B. And here's what the formula is. The probability of A or B equals the probability of A, the probability that A happens, plus, because it's the addition rule, plus the probability of B. Now remember, this is in general, and in other words, they don't necessarily are disjoint events, and so we would have to subtract the probability of A and B, and here's how we write that. The probability of A intersection B. And of course the word there is and. And so the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay. Now for disjoint events, we don't have the probability, any probability that we get them happening together. Like if we flip a coin, we can't get heads and tails. If we roll a die once, we can't get a 2 and a 3. They would be disjoint events. In other words, probability of A and B would be 0. And that makes our addition rule for disjoint events much more simple. And we don't have this part here because the and part, because there is no probability of A and B. So let's take a look at this example. What's the probability we draw a king or a 10? The implication here is we're reaching into a deck of cards at random. What is the probability we either get a king or a 10? So the probability that we get a king is 4 kings out of 52 total cards. The probability that we get a 10, we have 4 of those out of 52 cards. Here's our or word, and we have addition. And so 4 out of 52 plus 4 out of 52 is 8 out of 52, which equals 2/13. And there's our answer. Okay, next we're going to look at the multiplication rule. In general, if we see an and, we multiply. Now, we got to be a little careful. Looking at the example, go ahead and cross that one out and rewrite this. If we roll a die twice, so a die, that's singular for dice. If we roll a die twice, of course we get 1 through 6. What is the probability we roll a 2 on the first and a 3 on the second? If you're curious why I'm saying that this question that's written there is bad, talk to me later. I'll explain it. There's a couple of issues that one has. But anyway, we're going to roll a die twice. What's the probability we roll a 2 on the first and a 3 on the second? So roll a 2 on the first. There's one way out of, oops, let's turn my pen on. There's one way out of total of 6 total outcomes to get a 2. So the probability that we roll a 2 on the first is 1/6. Of course, probability that we get a 3 on the second is also 1/6. And because this is and, we multiply. 1 times 1 is 1. 6 times 6, 36. And so when you see an and, we're going to multiply. That's the multiplication rule. Okay, let's look at the more examples. You roll a fair die. What's the probability that you roll for part A, roll a 3 or a 4? So because we see an or, we know we're going to add. So the probability that we roll a 3 is 1 out of 6. Probability that we roll a 4 is 1 out of 6. Now there is no overlap. There's no probability that we get a 3 and a 4. And so we're just going to add. And we get 2/6, which of course is 1/3. Okay, so let's take a look at B. You do not roll a 3. Well, the probability of getting not 3 is 1 minus the probability that you do get a 3. So 1 minus 1/6 is 5/6. There's 5 ways to get something other than a 3 out of 6 total outcomes. Let's look at C. You roll twice and get a 3, then a 4. So when you see this then, we have to interpret a little bit. That's really saying and. Here's what it's saying. What's the probability that you get a 3 on the first and a 4 on the second? So we know we're going to multiply. So you roll a die twice, you get a 3, then a 4. So the probability that you get a 3 is 1 out of 6. Probability that you get a 4, 1 out of 6. And so we multiply. Boom. Okay, so let's look at part D. You roll 3 times and get all 3s. What that means is, what is the probability of getting a 3 on the first and a 3 on the second and a 3 on the third? So we multiply. That's the multiplication rule. When you see an and, you multiply. Okay, so here we go. You roll 3 times and get all 3. So the probability that we get a 3 is 1/6. Probability that we get a 3 on the second roll, 1/6, has nothing to do with what we got on the first roll. In other words, these events are independent. And on the third roll, we have a probability of 1/6. And because we have and, what is the probability that you get a 3 on the first and a 3 on the second and a 3 on the third? We multiply. And we get 1 out of 216. 1 over 216 is the answer. All righty. Have a wonderful night, and I'll see you in class.